Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. Welcome to this video on API Gateway versus Load Balancer in Microservices architecture. If you have ever wondered how client requests are handled in a distributed system or when to use an API Gateway instead of a load balancer, you're in the right place. In this video, we are going to talk about what an API gateway is, what a load balancer does, and the key differences between the two with real-world microservices context. And if you're preparing for a microservices interview, trust me, this video will help you build a crystal clear understanding of these essential components. Before we dive deeper, here's a quick look at what we'll cover in this video. First, we'll start with what an API gateway is and how it fits into a microservices architecture. Then we'll break down the key components of an API gateway, the parts that make it such a powerful tool. Next, we'll move on to what load balancing is and why it's crucial for distributing traffic efficiently. And finally, we'll discuss the key responsibilities of a load balancer and how it differs from an API gateway in both purpose and design. By the end of this video, you'll have a clear understanding of where each of these components fits and when to use which. Alright, so first, what is an API gateway? In simple terms, an API gateway is a server that acts as a single entry point for client requests in a system with multiple backend services, usually microservices. It receives the request, routes it to the right service, and then sends the response back to the client. Now, let's make that even easier with a real-life example. Imagine you walk into a restaurant. Instead of going into the kitchen and talking to each chef individually, you speak to a waiter. The waiter takes your order, passes it to the right chef, and then brings your food back to you. In this example, the waiter is the API gateway, handling communication between the customer and all the services in the kitchen without the customer needing to know what's happening behind the scenes. Now, have a look at the picture where I've placed the API gateway in front of all three microservices. Now first, we'll understand the role of the API gateway, and then we'll break down the key components of it. So suppose the client is sending a request to any one of the services. For this example, imagine the client is sending a request to the order service. 2. API gateway, middle layer. Instead of letting clients directly interact with each microservice, we have an API gateway in place. This is the central entry point. It receives the client's request and determines which microservice it should go to. Meanwhile, the API gateway will check the request URL and then redirect it accordingly. So if the request URL is for the payment service, the API gateway will send that request to exactly that service. 3. Routing to microservices. From there, the API gateway routes the request to the right backend service, whether it's the order service, product service, or payment service, depending on what the client needs. 4. Response back to client. Once the service finishes processing the request, the response travels back through the API gateway and then is returned to the client. Quick summary. So in short, the API gateway is like a smart router. It simplifies client interaction by hiding all the complexity of the backend services, improves security, and helps manage cross-cutting concerns like logging, monitoring, and authentication all in one place. Now that we know what an API gateway is, let's take a quick look at its key components. Some of the core responsibilities include request routing, authentication and authorization, and rate limiting. Don't worry, we'll break each of these down in more detail in the next slide. Now let's talk about the request routing component, what it is and how it actually works. Request routing is that part of the API gateway responsible for inspecting each incoming request and deciding which backend service should handle it. It looks at the URL path and then decides where to send that request. Basically, it's like a super smart traffic controller for your services. For example, imagine a request comes in /products/45. The request router sees that the path starts with /products and sends it over to the product service. Now, if the request was /orders/123, it would route that to the order service instead. So think of request routing like an airport traffic controller, guiding every incoming request to the right terminal, or in this case, the right service. Now, let's talk about rate limiting. Rate limiting is like a speed limit for your API. It's there to protect your backend from getting overwhelmed by too many requests, whether it's from a buggy application or even from a malicious attack. So the API gateway can set a rule like only 100 requests per minute per user or per API key. For example, imagine a user tries to hit the payments API 300 times in just 1 minute. But because we have rate limiting, the API gateway will only allow 100 requests in that minute and the rest will be blocked. Yeah, simple but powerful to keep your system healthy and stable. Before routing a request to any service, the API gateway first checks if the client is authenticated. That means, are they logged in and have they provided a valid token? Then it moves to the next step, authorization, checking if this client is actually allowed to perform the action they're asking for. For example, the client sends a request with a JWT token. The API gateway first validates that token, that's authentication. Then it reads the user's role from that token and says, alright, only if the role is admin can you access the /users endpoint. So authentication checks who you are and authorization checks what you can do. Load balancing is all about spreading out incoming network traffic like HTTP requests across multiple backend servers or service instances. The goal is simple: make sure no single server gets overloaded with too many requests at once. By doing this, the whole system stays fast, stays reliable, and can handle more users smoothly. Think of it like a restaurant with multiple waiters serving guests. When a big group walks in, the host doesn't just give all of them to one waiter, because that waiter would get overwhelmed and service would slow down. Instead, the host spreads them out, giving each waiter a fair share of tables. That way, every waiter has a manageable workload and customers get served quickly and efficiently. In microservices, load balancing works the same way, distributing requests so every service instance shares the workload evenly and efficiently. Alright, now let's take this diagram nice and easy, step by step, and really see how load balancing works, especially with hard to order service instances. 1. Client sends request. So first the user sends an HTTP request to interact with our services. 2. API gateway receives the request. Now the API gateway is the very first layer that catches this request. It takes care of authentication, rate limiting, and routing. Once it's sure everything checks out, it decides which service, maybe order, product, or payment, should handle it. 3. Request routed to load balancer. If it's for the order service, the API gateway passes it along to the load balancer. 4. Load balancer checks service instances, and here's where the magic really happens. We've got two instances of the order service, instance 1 and instance 2. Before sending the request, the load balancer does a couple of quick checks. Health check. Each instance keeps reporting back, I'm healthy or I'm down. The load balancer will only send traffic to the healthy ones. Load check. It also keeps an eye on how busy each instance is, maybe by counting active requests or checking CPU usage. Then, depending on the algorithm, the request goes to the one with the least load. 5. Request sent to the optimal instance. So, if instance 1 is free and instance 2 is already busy, the load balancer sends this request straight to instance 1. 6. Order service processes request and talks to DB. That chosen instance handles the request, could be placing or viewing an order, and it talks to its own database to get the job done. 7. Response sent back. Once it's ready, the response travels back the same way from the order service instance to the load balancer through the API gateway and finally back to the client. Quick summary. So, in short, the load balancer is like a smart traffic cop, watching which roads or instances are clear and sending cars or requests down the smoothest route. That way, traffic keeps moving nice and smooth and no single road ever gets jammed. Alright, let's wrap this up by looking at the difference between an API gateway and load balancing. API gateway. The API gateway is the entry point to your system. It takes care of authentication, authorization, rate limiting, and routing requests to the correct microservice. Think of it as a smart gatekeeper controlling who gets in and exactly where they go. Load balancer. The load balancer is all about spreading traffic evenly across multiple servers or service instances. Its job is to make sure everything runs smoothly and no single server gets overloaded. It's like a restaurant host making sure customers are evenly assigned to different waiters. If you like this video, please give it a thumbs up and don't forget to subscribe to this channel. Your little support really helps me grow here. And hey, press that bell icon too, because I'm going to cover all Java interview question topics from basic to advanced level. Thanks for watching. Then see you in the next video. Bye bye and keep learning.